Hello everyone. In this lecture, we will introduce the most important energy processing system, the power system. The power system is the most complicated system created by human beings so far. Thousands of families are involved. In this lecture, we will introduce the development of the power system and introduce the present situation of the power systems in China now. The rapid development of the smart grid provides good foundation for interdisciplinary research. Let's start this lecture. Before introducing the present power system, we have a brief review on the early history of the power system first. At the beginning of the power system, there's a debate between DC and AC systems. DC system is created and built by Edison firstly. In 1882, he built the first DC center station in New York, which can provide DC power supply to a lot of families for lighting. A few years later, two engineers, Westinghouse and Tesla, invented a polyphase AC inductive motor and a transformer. In 1895, they successfully built a three-phase alternating AC system on Niagara Falls and supplied electric power to Buffalo City, tens of kilometers away. In the same year, another engineer, Steinmetz, put forward the analysis of AC power system and solved the problem of analyzing AC power system. Because AC voltage level can be easily increased by the transformer, thus a loss of transmission is decreased. So in the following development, AC substitute DC gradually. But with the development of power electronic devices, the debate between DC and AC is far from over. This is a simple diagram of a power system supplying electric power to a city from the remote. The diagram below shows an AC system. The three power lines here means it's a three-phase AC power system whose main parts are power plant, transformer, and power line. Next, we will show you the photos of these parts. This is a photo of 900 megawatt generator in Shanghai Waigaoqiao power plant. You don't know its actual size since it's encapsulated in a steel box. Let's show you its actual size by the following photos. This is a rotating part in the steel box. It's called a rotator. This is a static part in the steel box. It's called a stator. By comparing the workers within the stator, you will know the size of the generator is very large. This is a thermal power. Water is heated by fire coal to generate steam. The high-speed steam pushes the rotator to rotate in the stator. The rotating movement cuts the magnetic induct line, thus generate electric power. Sometimes primary energy is not the energy of the steam produced by fire coal, but the kinetic energy of the water flowing from the high position to the low position. Water is driven by the penstock to drive the turbine to generate electric power. This is a photo of Tesla, which I took in Niagara Falls in 2003. We've introduced Tesla and Westinghouse built the first hydroelectric plant in Niagara Falls. This is a photo of actual hydroelectric generating set. Different from the thermoelectric generator, the rotating direction of the hydroelectric generator is vertical. In other words, it rotates in this direction. The rotator of the thermoelectric generator rotates in this direction. In other words, its rotating direction is horizontal. These are stator and the rotator of the hydroelectric generator. By comparing the number of the rotator gear, you can find the significant difference between hydroelectric generator and a thermoelectric generator. The speed of steam in the thermoelectric generator is much faster than the speed of water in hydroelectric generator, so there's a large difference between the number of their blades and their rotating speeds. The second part is a transformer. This is a 220 kilovolt single-phase transformer. These two terminals are for the input voltage, and these two terminals are for the output voltage. This is a 200 222 500 kV three-phase transformer. These three terminals are the input terminals of the three-phase, and the three terminals behind are the output terminals of the three-phase. The third part of the AC power system is power line. You must have seen these power lines in the wild. This is a common type in which three transmission lines are arranged in parallel. In this type, three transmission lines are arranged in upside-down triangle. This type is called a compact transmission lines. It covers less occupation land than the left type, so the whole transmission line costs less. We've introduced the part below. It's AC generation transmission distributing system. With the development of power electronic device, we can produce power electronic device with larger power. Thus, high voltage direct current system, that is HVDC for short, is built. HVDC system has two core parts. They are the rectifier and the inverter, which have been introduced in the previous lectures. You see, this is a photo of HVDC converting center in Guangzhou, China. This is a part of the 500 kilovolts HVDC system from Yunnan province to Guangzhou. By comparing the person in the photo, you can see that the size of the device is very large. In power systems, the voltage frequently reach hundreds or thousands of kilovolts, and the current through the transmission line frequently reach thousands or tens of thousands of amperes. The large current and high voltage have special characteristics. Here are two videos. In the first video, this is called the quadripartition transmission lines. That is, the transmission line is divided into four lines. Why? You will learn the reason in electromagnetic field course. We will give a brief introduction here. AC power system has a skin effect, which means current mainly flows on the surface of the conductor. The inside part transmits less current, can be taken out to form partition transmission lines. Besides the skin effect, AC and DC system both have corona discharge in non-uniform electric field. The first video shows the corona discharge phenomenon near the insulator of the tower pole by infrared camera. The second video shows the experiment of opening switch with load. In the experiment in the middle school, the opening and closing of the whole circuit is controlled by a switch. But when the current reaches 1000 ampere or more, it's very hard to open the circuit with a current. This video shows a living example. Besides the special phenomena with high voltage and large current, another hot topic in present power system is a smart grid. As we know, electric power is generated and transmitted in some form. It's distributed near the city and consumed by users. In the traditional power system, electric power is transmitted in one direction. But with the development of new energy, such as wind power and solar power, and new storage forms such as the electric vehicle and storage devices in family, energy can be transmitted from the user side to the distribution side, which makes the generation, transmission, distribution, and consumption more effective. In order to make the two-direction transmission of energy possible, we need smart data acquisition and communication system, and online monitoring, scheduling, control, and release system. On the left side of the diagram is the primary side of the power system, that is the side with high voltage and large current. On the right side of the diagram is the second side of the power system, that is the side with low voltage and small current. From the diagram, you can find that power system is the largest man-made system combining the energy processing and signal processing perfectly at both primary side and secondary side. Next, let's introduce the development of power system in China. From this diagram, we can see that the installation, that is the generation capacity of an installed generator, has a significant increase from 1980 to now. It reached 1,147 gigawatts in 2012. Let's introduce the state of the art in 2012. The whole installation capacity is 1,147 gigawatts. China's installation capacity becomes the number one in the world in 2013. Hydroelectric and wind power installation capacities are both the number one in the world. The whole consumption is 4.96 tera-kilowatt-hour in 2012. It's also the number one in the world. We need to point out here that since China's population is more than 1.3 billion, the average consumption per person per year is 3,815 kilowatt-hour. Let's take a comparison. In 2000, France has a population of 60 million, and its power consumption is 0.5 tera-kilowatt-hour. We can get the average consumption of per person per year is 8,333 kilowatt-hour. Although China's whole consumption is the number one in the world, there's a big gap in average consumption per person per year between China and the developed countries. China's power grid still has a long way to go. So far, besides the installation capacity and consumption rank the first in the world, China's power grid has other several world records. China has the largest power plant, that is a Three Gorges hydroelectric plant, whose installation capacity reaches 22.5 gigawatts. China owns the highest voltage level AC transmission line, which is 1,000 kilowatts, and owns the highest voltage level HVDC transmission line, which is positive and negative 800 kilowatts. This is a diagram of the power grid in China. The black line represents the 1,000 kilowatts AC transmission line. The red line represents a positive and negative 800 kilowatts HVDC. The purple line represents the 750 kilowatts transmission line. Besides, 500 kilowatt AC transmission lines covered densely in China. Well, this is the end of this lecture.